All right. Thank you guys very much for being here. It's truly an honor. And welcome to my talk. It's called BingBang, Hacking Bing.com, and much more with Azure Active Directory. And in this talk, I'm basically going to tell you the story of a research that I did earlier this year. It started out with an interesting-looking checkbox in the Azure portal. And crazily enough, it ended up with the ability to modify live search results on Bing.com in real time. And not only that, but also the ability to attack users through Bing, steal their Office 365 credentials, and gain access to everything in their Office 365 accounts. That means reading their Outlook emails, their calendars, their SharePoint files, and all the things that you can find in an Office 365 account. All of this because of a single mistake that Microsoft did. But Microsoft wasn't actually the only one that did this mistake. We found more than 1,000 different applications online that are vulnerable to the exact same flaws. So how do we do it, and how do you protect from these kinds of vulnerabilities? Let's dive right in. But just before we do, allow me to introduce myself. My name is Hillai Ben-Sasson. I'm 25 years old, based in Israel. My Twitter handle is very conveniently just @Hillai. I could not snatch the same handle on Threads, so I just gave up on that platform instantly. But you are welcome to follow me there. I post interesting stuff from time to time, and you're also very welcome to slide into my DMs. I'm a security researcher as part of the Wiz research team. I'm proud to be a Microsoft Most Valuable Researcher. You'll soon find out why. And like the rest of my team, I also specialize in cloud security research. And when I say specialize, I mean all of these. These are some of our team's previous vulnerabilities that some of you might have heard of. Cross-tenant vulnerabilities, supply chain vulnerabilities, etc., in many different cloud providers and services. And we also have a lot of good stuff coming up, good stuff in the oven, so keep an eye on our blog. All right, this is what we're going to talk about today. We're going to start out by learning what Azure Active Directory even is, just so we know what we're talking about in this entire research. Then we're going to dive right in to the flaws that we found in AD configurations that were basically the base of this entire research. Then we're going to talk about how we internet find vulnerable applications in the wild. Then we're going to get to the juicy part of the evening. We're going to tell, and not only tell, but also show an actual demo of the entire Bing story, how we were able to find a Bing admin panel vulnerable to these flaws that basically allowed us all that crazy level of access that I mentioned earlier. And not only that, but we're also going to show some of the other internal Microsoft applications that we found to be vulnerable to the same flaws. Then we're going to do a little bit of aftermath, talk about what Microsoft changed following this report and what you should probably change if you're an Azure customer as well. Then we're going to sum things up and send you on your way with, at the very least, a cool story to tell your friends, and also hopefully a couple of relevant takeaways. All right, so identity providers, what are they? Basically, whenever you go into a website or an app and you see all those buttons that go log in with Google, log in with Microsoft, log in with Tinder or whatever else, those buttons basically redirect you to different identity providers. The identity provider is a service that provides an app with everything that's related to the login process. The identity provider will take care of the user management, access management, identity management. All the sign-in and sign-up flows will happen within the identity provider, and the identity provider will provide that information back to the app. It looks something like this. You as a user, you go to the identity provider, you type in your username, your password, or whatever. The IDP will give you back a token. You will take that token, give it back to the app, and the app will sign you in. So that's what an identity provider is, and one of the most popular identity providers in today's market is called Azure Active Directory. Actually, it's not called Azure Active Directory anymore. They changed the name like last week to Entra ID, but I couldn't even find the logo for it. That's how new this changes, and also the slides are already made. So we're going to stick with the old branding for now. Azure Active Directory is a very popular identity provider made by Microsoft, obviously. It integrates very well with Azure and with on-prem Active Directory environments. Even if you don't recognize the name Azure Active Directory, you will definitely recognize this login screen. You've probably seen it millions of times already. I can see some of you are getting PTSD just by looking at it, but don't worry, it's just a screenshot. So just so you know, whenever you see this login page, it almost always means that Azure Active Directory is powering behind the scenes. Now, what actually happens behind the scenes when you go into that page and type in your username, password, your OTP, or whatever else your organization is using? What happens behind the scenes when you do that? This is going to be a little bit technical, but bear with me because it's very simple. Your browser will send this HTTP request to AAD. It will provide AAD with your tenant ID. Is that laser working? All right, with your tenant ID, which is basically the organization that you belong to, the company that you're a part of, with the app ID that you're trying to log into, and with your credentials. If the login was successful, Azure will provide you with one of these bad boys. This is called an OAuth token, and it's basically a JSON containing all sorts of information about your identity, what's your user ID, what's your tenant ID, basically all that sort of information that the app needs to know about you. And that's basically how this process works. Oh, and this entire thing will be signed, digitally signed by a private key belonging to your Azure tenant, so that people can verify that it's a legitimate token. All right, told you it was simple. Now let's dive into our research and basically how it even started. So we were sitting in our offices in Tel Aviv, doing what any good researcher does, and don't tell anyone, it's a trade secret, but what a researcher does most of the time is just clicking on buttons until something interesting pops up. So we were doing basically that, clicking on buttons, and then something interesting popped up. We were creating an app, a web application, using Azure App Service, which is how we create a web application in Azure, and we wanted to add authentication to our app. So we chose AAD, naturally, and we presented with this very simple form. There's almost nothing, no choices in this form, but there is one important choice that you have to make, which is the checkbox at the bottom of the screen, which makes you choose between a single-tenant app and a multi-tenant app, meaning an app that is only visible to your tenant, to your company, or to more than one organization, more than one company. That choice looked very interesting to us, because what does that mean to be a multi-tenant app? Does that mean that any tenant can log into my app? Does that mean that some tenants are allowed to log into my app? What happens when I click this button? And who actually does the validation here when I click this checkbox? Do I have to do the validation? Does Azure do it for me? Basically, what is the shared responsibility model here? So we dived in, and I checked out what exactly does Azure validate for you when you create a multi-tenant app. It turns out that out of this very big token that contains all sorts of information about your identity, these are the parts that Azure App Service will validate for you when you create an app. It will validate the audience field, which means the app that you're trying to log into. It will validate the not before claim, which is the start time of the validity of the token, and the expiry time, which is the end time of the token. Basically, it will make sure that you're logging into the right app, that your login is not from the future, and your login is not from the past. But besides for those three things, all the rest of the fields here will not be validated by Azure App Service at all. If you want to validate, for example, that the user is coming from a certain tenant or from a certain subset of users or groups, you will have to write your own code that does this validation, as Azure App Service will not do it for you. So to recap, whenever you create an AAD app and you click this checkbox, everyone will be able to log into your app. And when I say everyone, I mean everyone. Every single user and every single tenant or company in Azure, whether it's your organization, the competitor organization, some user that someone created 5 minutes ago, everyone will be able to log in successfully. And if you don't want it to be like that, you will have to write your own code that dictates otherwise. So this is basically the first flaw that we found. We realized that people will probably click this checkbox thinking that Azure will do this validation for them, and being mistaken, as the Azure validation is far from being comprehensive. That way it will be exposed. But right after thinking this up, I instantly had another thought, which is, what if the app developer did know that he has to do all these validations? And what if an app developer does check that I'm coming from the right tenant? Will I be able to bypass that sort of validation as well? So I went back to the request that you saw earlier that I was sending to Azure, and I saw that one of the parameters that we're passing here is my own tenant ID. If I'm coming from Wiz Research, I will pass the Wiz Research tenant ID when I'm logging in. I was like, wait, what if I just change this from my ID to your tenant ID? Tenant IDs are public information. They're not considered secrets at all. If I want to know what Microsoft tenant ID is, or Google's, or Amazon's, I can just Google it and it will probably come up. It's by no means considered a secret, so I just changed my own tenant ID into Microsoft tenant ID, and it turns out this just works. You can log in under any tenant that you want to log in under, and if before, when I logged in, I got a token that said my user is Hillai Ben-Sasson and my tenant is Wiz Research, I can now create a token that says my user is Hillai Ben-Sasson, but my tenant is Microsoft, is Google, is Amazon, or is any other company that I want it to be. Why is this dangerous? Let's say I create an app on the Wiz Research tenant, and this app is really secret. It contains all of my 0 days and my banking information and whatever else that you want to imagine is in there. So I really want to protect this. I write my own code that checks every user that's logging in. What tenant is he coming from? And only the Wiz Research tenant will be able to log in. Now when an attacker finds this app and he tries to log in, his user will be attacker user and his tenant will be attacker corp. My code will see that he's not coming from Wiz Research and access denied. But the same attacker finds out about this trick that I showed you a second ago, and he logs in again. This time, his username is still attacker user, but his tenant will say Wiz Research. My code will check his tenant ID, sees Wiz Research, and suddenly, access granted. That attacker has access to all of my secret information, although I did check my tenant ID. This was basically our second flaw. So to recap, our first flaw was in the realm of customer misconfigurations. Basically, I create an app, I click this checkbox expecting Azure to protect me in some sort of way without fully realizing that I do have to write my own code that validates this type of information, and Azure doesn't do it for me. And the second flaw is in the realm of insufficient checks. Basically, I do realize that I have to do my own validation, but in my own validation, I trust the tenant ID that Azure is providing for me to be accurate. Well, in reality, it is not to be trusted by itself, and anyone can basically just put whatever they want in the tenant ID field. But here's the thing, any schmuck can just come up and say, these are theoretical mistakes that some people can theoretically make, but it's not a very compelling story if no one ever did those mistakes, right? So what I wanted to prove basically was that people actually do make those mistakes in the wild, and it's not just something that I made up. So our next step would be to scan the internet, to try to find vulnerable applications in the wild, and basically prove my little thesis here, that those are mistakes that are very easy to make, and people will inevitably make them. So this is basically how I approach this. Starting out by getting as many Azure App Service domains that I possibly can to have a very wide pool to choose from, to scan from. Then I wanted to throw away any non-existing apps, basically any dead links, anything that wasn't alive in the moment that I started the scans. Then I wanted to filter out only apps that actually use AAD as their locking mechanism. And out of all the AAD apps, I wanted to filter apps that are configured as multi-tenant, because that was the focus of my research. Then, when I had all of those, all that's left for me to do will be to log in and see what's behind the curtain. So this is how I did all those things, starting by getting Azure App Service domains. How do those even look like? Basically, when you create a web app on Azure, you choose some sort of name, and the domain you get will be thatname.azurewebsites.net. So basically what we're looking for here is subdomains. So let's add some subdomains. To ask myself where do we find domains, we first ask ourselves where are domains even born, right? So that's DNS, and enter passive DNS. What is passive DNS? Apparently, your ISP has another income stream besides your monthly bill in the form of selling your data to various third parties. As passive DNS databases are basically databases of DNS queries that people online are making right now, sourced from ISPs, hosting providers, enterprises, etc., and can basically give me a live outlook as a researcher, a live outlook on what domains people online are looking for right now. That was a very good source of information. We listened in on one of those databases for a couple weeks, and we got literally millions of unique Azure websites domains. Our next step would be to HTTP scan all those apps and throw away anything that was non-existent, all the 404s, all the dead domains. Basically, in those types of databases, there is bound to be some percentage of garbage. People will make typos, will make mistakes. So I wanted to scan those apps, see what's actually alive, and throw away all the garbage. So after throwing away the garbage, we wanted to find apps that actually use Azure AD as a locking mechanism. How do we do that? As you remember from before, our beloved login screen will have to pop up in order to authenticate you to AD apps. So I basically looked for any apps that redirect to this page, whether through browser redirects or unauthorized responses pointing to this page. This way I knew that the app was using AD. Now, my next step would be to find only apps that use multi-tenant. How do we do that? There was a little bit of a tricky part because we didn't want to just log into all those apps. There were hundreds of thousands of apps. We didn't want to spam them or Microsoft with our sign-ins. We ideally wanted to find a way to fingerprint this from the outside. So we went back to our iconic login page. I took a look at what it looks like behind the scenes. Basically, as you can see, there's a little bit of HTML and then a huge chunk of barely readable JavaScript code. This is not on Microsoft. This is just JavaScript. But I basically wanted to dive into this bowl of spaghetti code to try to find anything that is interesting. Then I found this thing, a variable called isGlobalTenant equals true, where, as you can probably deduce, in non-global tenant pages, this will be false. So now I had a way to fingerprint applications and find out from the outside if they're multi-tenant or not. So I was now left with Azure App Service domains that are actually alive right now, use Azure Active Directory to logging in, and are multi-tenant. So all that's left for me to do was to log in. So this is what I found. Out of over 5,000 multi-tenant apps that we found in our scans, almost 1,300 apps were vulnerable. How do we define vulnerable? Basically, it wasn't enough for us that our login was successful. Those are multi-tenant apps. Every login will probably be successful. We wanted to see what happens after we're logging in. We filtered out anything that returned an error code, an error message, redirect back to login. Only successful responses were counted as apps that are actually vulnerable to this sort of authentication bypass. Even out of those successful responses, we filtered out anything that looked default, meaning the login was successful, the response was successful, but suddenly the app goes, welcome to Azure, please set up your new app. We filtered out those as well. We didn't count those. We only wanted to find actual live apps. Those apps were also pretty spread out. They were across over 500 different vulnerable organizations, so it wasn't just one company running it for everybody. It was clearly a spread out problem. And if you crunch those first two numbers, you find that almost a quarter of all the multi-tenant apps we scanned were vulnerable to this, which is a pretty crazy figure. But here's the thing. In my own research philosophy, at least, quantity is important. It allows you to see like what's the scale of a problem. Is it something that I should care about, or is it something that's maybe niche and little? But quantity by itself wasn't what I'm looking for. I wanted to look for quality findings, meaning how many of those 1,300 applications are actually super interesting internal applications that have to be reported right now, and how many are just not that interesting. And here's the thing about misconfigurations. Sometimes they're just configurations. Sometimes people want to leave the door open to everybody, and that's okay. So how do we figure out which apps are interesting and which apps are just we have to, inevitably, there's going to be a human being that's going to look at all these apps and go, this looks interesting, we should report it, or this doesn't look interesting, but it's not possible to do that on 1,300 vulnerable apps. We wanted to find a way to basically narrow out our prism a little bit and find some sort of case study that we can focus on. So choosing a case study, the first question we asked ourselves basically is who has the best bug routing program that we know of in this industry and is also coincidentally a very big Azure customer. I'm talking, of course, about Microsoft. The great folks at the MSRC have always been very professional and responsive to our reports. So shout out to them. Shout out to you probably. I'm assuming some of you are in the crowd right now. How do we actually find out which apps are Microsoft? Basically, each application that we found, we queried on Azure's Graph API and got a lot of info about what this app does and who it belongs to. And one of the fields was called App Owner Organization ID. As you can probably deduce, this was the tenant ID hosting the app. Tenant IDs are public, as we said, so we just gathered a list of all the Microsoft tenants and knew that the apps that we're looking for are actually Microsoft. After this deduction, we were left with a much smaller and much more manageable list of apps to look at, about like 100 or 200 apps, something that I can actually look at with my own two eyes and figure out what's interesting and what not. And when I scrolled through this list for the first time, one domain instantly popped into my eyes. It was bingtrivia.azurewebsites.net. I instantly looked at this and I was like, wait. Is this Bing as in the Bing, like one of Microsoft's biggest assets, the search engine Bing.com? Or is this some sort of maybe naming convention I don't understand? Basically, I wanted to find out what's in this app, which brings us to our next, part, which is the demo of our Bing attack. Let's head right into it. Bam. Oh, this is the wrong screen. Whoa. There we go. All right. So I basically went to my browser and typed in that address and pressed enter. I was, of course, greeted by this infamous login page that we all know and love. Now, the old me at this point would probably looked at this and said, okay, there's a login page. Let's give up. Alt F4 and continue to the next page. But knowing what I know now, I just very confidently typed in my own credentials. As you can see, they're @WizResearch, nothing to do with the Microsoft tenant. Typed my own password and my own OTP code because we're very secure. And my login was successful. I was presented with this page after logging in, which, as you can see, is pretty much meaningless. Just a big table with hundreds of links in it. And just by looking at this homepage, I couldn't really answer any of the questions that I had going in. Like, what is this app even for? What is its purpose? Is it actually related to Bing.com, like I thought, or is it something that unrelated that I don't understand? And most importantly of all, was this app meant to be exposed to Hillai at Wiz.io, or was this some sort of horribly misconfigured internal app? I couldn't answer any of these questions just looking at the homepage. So I wanted to dive in further and start probing in more. 1 second. All right. So I again started clicking around until something interesting popped up, and then clicking on the carousels link, this page popped up, which was basically another table. This time it contains a list of phrases like iconic female video game characters and highest mountains worldwide. Sort of sounds like search queries, right? So I clicked one of those pages, the one that said award-winning soundtracks or best soundtracks, and when clicking on this button, I found another list of what seems to be good movie soundtracks, I guess, sort of like search results, which begged the question, could this be that this old 90s looking app is actually controlling live production content on Bing.com, or was this some sort of maybe a test environment or a local copy or something? There was basically only one way of finding out. We wanted to temporarily modify one of these entries to see if our change reflects anywhere, and then of course doing it in a way that would be easy to revert, and then of course reverting immediately and reporting to Microsoft. Now, as you might remember, the list that we're looking on right now is supposed to be allegedly a list of the best movie soundtracks of all time. The first entry here is movie Dune from 2021, which I'm sure has an amazing soundtrack. But when I think of best movie soundtracks of all time, I think of one movie and one movie only. I'm talking, of course, about Hackers from 1995. Yeah, absolutely. We wanted the results to reflect this. We basically clicked the little edit button next to Dune and started filling out all the details to our favorite cinematic masterpiece, including image, link, basically all the details that you could possibly think we're filling in, we filled in. And almost immediately after clicking updates, the search results for best soundtracks on Bing.com changed to the result that we just entered. Yes. Absolutely crazy. We were very quick to want to revert this and report everything to Microsoft, but just before we did, we wanted to answer one final question that we had, which is this panel also vulnerable to an XSS attack? XSS stands for cross-site scripting. It's basically a form of attack where an attacker is able to inject their own JavaScript code into an otherwise legitimate web page and have that code execute on clients. So we wanted to find out if our access enabled that as well. So we added to the result a harmless XSS payload. It basically did nothing but prove that it existed, and we updated, and that payload ran successfully, meaning that we had an XSS ability on Bing.com. Which was absolutely crazy find, two absolutely crazy finds. So we quickly reverted all of our changes and reported everything to Microsoft and started working with Microsoft to help fix this as much as we can help. But as we were working with Microsoft on the report, one thing did not leave my mind. One burning question. We had an XSS ability on one of the largest websites on the internet. And it wasn't even a very sophisticated attack. I mean, we came to it from an educated point of view, but anyone could have just put in their own credentials and their logging would be successful. So I asked myself, what can an attacker have done with the same access that we had? Again, like a good researcher, I went back to Bing.com and started clicking on buttons until something interesting would pop up. Almost immediately, something very interesting popped up. I was actually on the homepage of Bing.com, and just below the search bar, I suddenly saw my own Outlook emails right there on the Bing.com homepage. I was instantly like weirded out by this, like, why are my emails on this homepage? Did Bing hack me back or something? What's going on here? But after calming down, I realized that this was actually a feature. Bing has a Bing for Work section that allows you to search through your own organizational directory using the Bing search engine, which is maybe a very cool feature for customers, but for me, it was even cooler, but because I thought if Bing could do this, then I could probably do this too with my own XSS. So I started looking around the requests that Bing was making in order to do this, and I found that this was basically the flow here. Your client, your browser, goes to Bing and asks Bing to generate an Office 365 access token for your user, and Bing can apparently just do that. It can generate an access token on your behalf to Office 365. Bing gives you back the token, and the client goes directly to Office 365 with that token and asks for whatever he wants to get and gets it. So I looked at this flow and I was like, amazing, because if your client can do this, then I can definitely do that as well. So I sharpened my JavaScript skills a little bit and made this XSS payload that basically mimics that behavior. It goes to the same big API. It creates an Office 365 access token on the logged in user's behalf and exfiltrates that token back to the attacker. Now, we demoed this behavior. Obviously, we did not attack any Bing users. That would be highly irresponsible. We did this on our own demo environment. In that demo environment, my computer was the victim computer, and my coworker's computer was used as the attacker computer. Now we're going to see the victim's point of view, basically, and just see what I'm doing here. I'm not going to click on any buttons. I'm not going to download any files. I'm just going to browse to bing.com, and that's it. And look at what happens when I refresh the page. Look at all this info that the XSS is able to get out of me. It can see my full name, my email address, my Azure identifiers, and most importantly, it can generate a secret access token on my behalf that can be used to access Office 365 from my own account. So the attacker just ran this payload. He got this token that you're seeing here, exfiltrated back to him. And now you're going to see the attacker's point of view. He's going to run this script on his machine and paste my secret access token into it. And almost immediately, you can see my real live Outlook inbox with my actual emails from that day. This is not Hollywood magic. This is my actual inbox. And not only that, we were also able to see not only my Outlook inbox, but my Outlook calendar, my Microsoft Teams chats, my SharePoint documents, my OneDrive files, basically all the secret information that your organization is probably using, that our organization is at the very least using. All of that was basically exposed to everyone who would be attacked by this attack. All right. So this was basically the Bing story, but Bing wasn't our only find here. After reporting the Bing issue, we continued down the domain list to try to find if there are any other Microsoft web apps that are also vulnerable. This is some of what we found. This panel that you're seeing right here is the control panel for the MSN newsletter, which apparently still exists. It allows you to create your own emails with your own images and links and whatever, send them from a trusted Microsoft email address to a huge audience list. We also found some internal APIs. This one is called Centralized Notification Service. It basically has to do with internal developer notifications for Microsoft. We did not only have access to read those notifications, but also to create new notifications and post them into internal Microsoft developer pipelines. This API is for contact center, it's called. It's basically all the customer service call centers that Microsoft does, information about customer service agents and telephony and physical sites. All of that was available in that API. This one was actually kind of funny. This is called Polycheck. This is apparently an internal Microsoft CI/CD tool that goes over your code to try to find any non-politically correct terms in there. And this is basically the brain behind Polycheck. This was a centralized database of all the no-no words that Microsoft gathered, categorized by severity level and why they're sensitive, with like lengthy explanations. This info was available for over 100 different languages, so definitely a database that you would not want to leak outside. All right, what you're seeing here is a blog. It's called the Microsoft Power Automate blog. As you can see at the top, it's hosted on Microsoft.com. And it's a very active blog where Microsoft posts on product updates. Like the new version is out, you can download it here. What you see here is the WordPress admin panel, yes, WordPress, that powers that blog. This screen is the edit post screen for the blog you saw a second earlier. We can edit the HTML. We can change the link that goes, download the release here to whatever link we want it to be, post our own, iframes, etc. And this will all be posted to Microsoft.com. And finally, this system is called Cosmos. It's a storage management system that manages over 4 exabytes. An exabyte is 1,000 something petabytes of Microsoft files. As you can see at the bottom, they're divided by internal Microsoft divisions. Like these files are for the AI division, for the cloud division, for the marketing division. So this absolutely looked very internal. Just by seeing this homepage, we quickly reported it and didn't touch it any further. All right, let's talk a little bit about the aftermath of this report. Whoop. All right, starting by the Microsoft side. Obviously, we reported all these issues to Microsoft immediately after finding them, and I worked with Microsoft as much as we could to try to help our customers and their customers to fix these issues. All the applications that we reported were found to be out of scope for the bug bounty program. However, Microsoft did award us $40,000 bug bounty, which we donated for the AD product and guidance improvements that our reports help make. So product and guidance improvements, what are they? First of all, Microsoft did a major documentation and guidance overhaul, which is basically the most basic and important thing. Now, when you want to create a multi-tenant app, you will have much more helpful documentation on how to do this properly. Furthermore, in terms of features, Microsoft changed this behavior that I talked about before, and you can no longer sign in under a different tenant than your own. The thing that you saw me do earlier, when I can log in under Google, Amazon, or Microsoft, or whatever else I wanted to, you can no longer do that without explicit permission. Which is always a good change. It is worth noting that there are several exceptions to this rule. According to Microsoft, they're about 1% of the ecosystem, and customers were supposed to be notified. But apparently, some apps depend on that behavior still in order to function. They also added some new configuration options, the most important one of which is called AD Allow Tenants. Basically, you give a list of tenant IDs, and only those tenants will be able to log into your app. If before you had the choice between all or nothing, now you have the choice of something, which is always a good choice to have. Now let's talk a little bit about the aftermath for Azure customers. All these changes that I just mentioned are Microsoft changes that tools that help you build your own secure environment, but this is ultimately still a customer-facing issue. Microsoft cannot write your own code for you, and this is what I would suggest if you're an Azure customer and you think this issue pertains to you as well. First, I would suggest to manually check all apps that you have multi-tenant and check if there's a real business need for them to be multi-tenant. If not, then I would obviously advise for the principle of least privilege and change them back to single tenant. But if you do have to make them multi-tenant, I would suggest to review your authorization logic for each app. Do not rely on Azure's built-in checks alone, because as we've seen, they are far from being comprehensive. You should implement claims-based code within your own code, claims-based authorization within your own code, and consult the Microsoft documentation to make sure that you're doing it properly. For more guidance, I would suggest checking out my blog at the Wiz website or the MSRC blog, the Microsoft website. Both of those also link to each other, and I think that the slides are supposed to be available later if you don't want to copy those by hand. All right, let's sum things up with some important takeaways that I think are relevant from this research. First of all, in the cloud, external exposure is much, much easier to do than in on-prem environments. We all love using the cloud because it's very agile and it allows you to, spin an entire network worth on computers in a click of a button. But it's also worth noting that all this network can be exposed to the internet directly in the same click of a button. So it's important to always keep this in mind when working in cloud environments. The next exposure can literally be one click away at all times. In terms of cloud services, each cloud service has a very different shared responsibility model than its competitor or the previous service that you used. So whenever you introduce a new service, you have to make sure that your developers know exactly where the line in the sand is drawn, which parts are my responsibility to do, and which parts are the cloud provider's responsibility to do. Because if you don't know exactly where that line is drawn, you're bound to make the sort of mistakes that Microsoft did here. And finally, this is sort of a generic takeaway, but it's also very relevant here. Monitor your environments. Always enable logging on your important services. In the cloud, it can be very, very costly, but ultimately, this will be the only way for you to track any unusual activity going on in your tenant. Like a research user suddenly logging into your multi-million-dollar search app. All right. Thank you very much. Any questions? Okay, thank you. Those are the questions thing work. All right? All right, so thank you.
A quick question, if you're still taking questions.
Yeah. Where are you?
Over here.
I see you. Yeah.
So what was the legality of modifying data, especially since the resources weren't within scope of the bug bounty?
Let's come up to me and let's talk about this. Yeah.
Right. I have a question.
Yes.
Do you have any configuration recommendations document that you posted?
Yes. Within our own blog and also the MSRC blog, we posted a lot of ways to also look for these sorts of configurations within your environment and what's the correct way to make multi-tenant apps, how you should write your own code, and how you should do these checks in a proper way to not find the same pitfalls. I would highly suggest checking out our blog for these guidances.
Did you find vulnerabilities in non-multi-tenant apps?
This research was basically focused on multi-tenant apps. Both of these flaws were within multi-tenant. We're always working on finding the next interesting thing, but in here it was focusing on multi-tenants.
Thank you.
Thank you. All right, feel free to come up if you want to ask more questions. Thank you.